The question we're exploring today is what holds atoms together? We are going to be talking about two separate forces that keep atoms together, but before we do that, we need to talk about the structure of an atom. Atoms are tiny particles that make up everything. If something has mass and takes up space, then it is matter, and that matter is made of atoms. Atoms cannot be created or destroyed, and they cannot be subdivided, meaning they can't be broken apart. There are instances where this can occur, but only in specific reactions called nuclear reactions. In regular chemical reactions, that can't happen. Every element on the periodic table is made up of unique atoms that has unique intrinsic properties. As an example, hydrogen has very specific properties such as boiling point, melting point, and density, and copper has its own specific properties. Those properties are intrinsic to those atoms that make up the element. The structure of an atom is broken down really into a couple of different parts. We're going to use what's called the Bohr model to help us visualize what an atom looks like. This model is not the most up-to-date model, but it's the easiest to help understand and visualize what atoms really look like. In the center of an atom is the nucleus. The nucleus is broken down into protons and neutrons. Outside of the nucleus, you have electrons. Electrons, you can see, are on rings, and the electrons are negatively charged particles. The protons are positively charged particles. As you can see on the red spheres inside the nucleus, there's a little positive charge there. And the neutrons have no charge. So please make sure to record in your notes, protons are positively charged, electrons are negatively charged, and neutrons are neutral and have no charge. Each element on the periodic table can be identified by what's called the atomic number. The atomic number refers to how many protons are in the nucleus, and the number of protons in the nucleus defines the element. If you have one proton in the nucleus of an atom, it's hydrogen. The definition of hydrogen is one proton. If a nucleus has two protons, then it's helium. The definition of two protons is helium. In this image, on the right-hand side is beryllium, and I know that it's beryllium because beryllium is number 4 on the periodic table, and in order to be number 4 on the periodic table, you have to have 4 protons, and this model clearly shows 4 protons. Something that's important is to get perspective on the size of an atom. So if you think of an atom as this football field, it looks like a Michigan State football game. The entire stadium would represent one atom. The nucleus within the atom, which houses the protons and neutrons, if you were to run down to the very center of the field and place one tiny grain of sand at the very center of the football field, that tiny grain of sand would represent the size of the nucleus compared to the overall size of the atom. So the atom is the entire football field, and the nucleus is that grain of sand in the very center. The nucleus is tiny, and the majority of the atom is made up of empty space. The electrons are outside of the nucleus, and they're flying around doing their thing outside the nucleus, but the majority of the atom is empty space. And so the majority of the volume of the atom is where those electrons are in what's called the electron cloud outside the nucleus. Of course, we don't actually draw atoms that way. We draw atoms, as you can see in this model, so that you can actually see the protons and the neutrons. And you can see here that the size of the nucleus in this model is way bigger than it should be, but we do that so we can actually visualize what the atom looks like. All right, so what holds that atom together? Well, there's a couple of different forces that hold the atom together. So we're going to talk about two forces. The first is called an electrostatic force. Another term for this is the electromagnetic force. We'll use those interchangeably. The electrostatic force or electromagnetic force is the force between opposite charges. Like charges repel each other. As an example, if you have two positive charges next to each other, they repel. If you have two negative charges next to each other, they will also repel each other. If you have opposite charges, like one positive charge and one negative charge, they're actually attracted to each other. So if you think about the atom, if electrons are negatively charged and protons are positively charged, they're attracted to each other. That's called an electrostatic force. This force, also referred to as the electromagnetic force, keeps the electrons near the nucleus of an atom and keeps the overall atom or atomic structure in place. There's a second force. This second force is called the strong nuclear force. This strong nuclear force keeps the nucleus from breaking apart. So there's two things that hold atoms together. The nucleus needs to stay together with the strong nuclear force, and the atom needs to stay together with the electromagnetic or electrostatic force. So if you look at this model on the right, if you look at all those positive charges in the center, those protons, there are a total of 7 protons in the nucleus of that model. Well, we just said in the previous slide that positive charges repel each other. So what's keeping those positive charges next to each other is the neutrons. The neutrons, which have no charge, act as a buffer system to prevent the positively charged protons from moving away from each other. So a nucleus is able to hold a lot of protons all positively charged next to each other because the neutrons kind of buffer that system. That's called the strong nuclear force. The neutrons prevent repulsion between the protons and holds the nucleus together. When both of these forces are acting in tandem, meaning they're acting together, we say that there's enough binding energy to hold the nucleus together, and that atom is said to be stable. If there isn't that binding energy, or the binding energy is not great enough, the atom is said to be unstable.